Oh, thank you. So here to talk to you about Prometheus and how it applies to microservices, as well as giving you some tips that apply to monitoring generally, and not just Prometheus. So just some background as to who is going to have your attention for the next 20, 30 minutes. My name is Brian Brazel. I'm Irish. Just flew in like 6 hours ago. I'm one of the core developers of Prometheus. I also own a company called Robust Perception, who also does the consulting and support stuff around open source. So that's two companies doing this meetup. Previously, I worked at Google for, was it 6.5 years? Doing lots of monitoring stuff there. I was at a startup then called BoxServer for a while before doing my own thing. So when people say monitoring, what they mean varies a lot. Because I've had people who I say, oh, I do monitoring. They think I do employee monitoring, like, checking what you're looking at through the proxy logs. Or they think I mean, oh yeah, you mean you've got basically a NOC and a wall of people looking at monitors, which is the exact opposite of what we're about. So I just like to clarify what I mean by monitoring so we're all on the same page here. Because I see there's basically 4 purposes for monitoring. The first is you want to know when things go wrong, okay? Because that's mainly what people think about. So if there is some business level issue there, you want to know when it has happened or is about to happen so you can try and fix it. The second thing is when you have a problem, you need to be able to debug it. You need to figure out what's going on. And even when there isn't a problem, you want to know what's going on inside your systems. The third thing is a bit more long term. You want to see trends within your system over time. You want to be able to say, hey, my cache hit ratio is 80%. Therefore, I can take advantage of it to do blah, 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 and make a business or engineering decision based on that. As well as saying, hey, actually, we need more machines because we're going to run out in 3 months, or tomorrow, as the case may be. And the fourth one, which is a little bit different, is sometimes you're just using it for plumbing. You need to feed it into something like, at the end of the day, if a hard disk has failed in a machine, you have to send someone in to fix it because the robots aren't ready yet, right? You have to send an alert for that particular machine, or maybe your QA processes, or your security processes, or anything else like that. You're going to have to just plumb it in somehow. And that's the fourth case where monitoring comes in. Not quite as tight to the rest, because not quite so human involved, but it is an important thing that you have to support. So let's look at what a microservice is here. I can just speak louder, Is this better? Okay. Hopefully no feedback. Okay, oh yes. So a microservice architecture, it has a few features which are relevant for us when monitoring. The most obvious one is the microbit, that you've got lots and lots of tiny little services. Itsy-weeny ones. The services are all talking to each other. They could be written in quite a few languages. They might have some Ruby, some Node, some Go, some Python, some Java. And also, because it's a microservice architecture, you're adding and removing services fairly regularly. Like you're probably doing that on a monthly basis anyway. Hopefully not weekly. So when I'm just talking in general, not about just microservices, there are lots of common monitoring challenges I see talking to companies. And that is that the tools that are out there, a lot of them are limited and, more bluntly, painful. They're limited technically, they're really, really hard to scale, and they're also limited conceptually. An example I always use is if you've got a monitoring system, like say something similar to Nagios, all you can really alert on is, hey, we're at 90% CPU. That's not what actually you care about. What you care about is my service is too slow and my customers are noticing, which is a latency problem. But if all you have is Nagios, which only looks at a machine, you can say, yep, this machine's at 90% CPU, wake someone up. Oh, look, it's just a cron job, it's over by now. Oh, well, go back to sleep now. That kind of sucks, And what you end up with is pager fatigue. People who woke up in the middle of the night for no reason, really. That's kind of annoying. So for microservice monitoring, you've got some additional challenges. So if you are having services added and removed, you don't want to have that to be a 3-month process with ops to make that happen in monitoring, as that kind of defeats the whole purpose of microservices. You've also not just services being added and removed, but machines or images or auto-scaling. All of these things are a normal thing you have. That needs to be happened by magic, preferably with no human intervention at all. Another thing is because each team is running their own services, they don't all have the same view of the world. If I show a machine and show that to the database team, say, versus the actual infrastructure team, they'll have very different views of the world. The infrastructure team, they're like, ah, yes, Machine foo, it lives on rack bar. In data center Z, it's pulling from such and such a power conduit. Grand. That's how we think about things. Talk to the database team. Oh yeah, that's the staging server for Team Baz, which we use on Tuesdays, except every second month. You know, two entirely different views of the world, and you know those can clash. Because how do you have a monitoring system that knows about both of those and deals with them sanely? Because only one of those teams is really going to win, or rather, at most, one of those teams is going to win that one. Likely neither of them. And then you've got all these different languages and types of server, because maybe there's Postgres, you've got some Mongo in there, some MySQL, maybe all 4 MySQL forks by now. Are there 4 of them by now? Is it 5? You know, all of these are there. It can expand with this when you're doing with this. So what we kind of need to look out for is you need monitoring is actually designed for this sort of very dynamic environment that works across multiple languages, that you have the potential that you can decentralize your monitoring across teams, and you can do lots of analysis. And you know, if you have services that are similar, like please tell me you do have an RPC library at least that's shared, please. Then you know you can take advantage of that to make life easier for everyone. Because the thing is, there's a lot of monitoring systems. They're just here's your server. It's just looking at the edge of it, you know. And maybe it says, oh yes, talking to Postgres at the back, and this is what it looks at. Like it's pre-coded. Hey, I know about these Java classes. I've instrumented them, like the standard HTTP server classes or so on, the server classes. But in reality, if you think of your microservice, you've got a kind of a fractal thing all the way down, because inside each of your services, it had subsystems, and they kind of, you know, are like mini tiny microservices all living inside your process. So what I say to you, and kind of the idea behind Prometheus, is you take all this, and inside each of these, you individually monitor them, and it's all pulled back then out to Prometheus, and you monitor as a whole. And furthermore, rather than having just to worry about machines, you look at services. I don't care about one machine failing or one machine being slow. I care about if the service across however many machines is doing okay. If one machine fails in the middle of the night, the correct response is to keep on soundly sleeping and deal with it next business day. It is not to wake someone up just in case, because that's what we should be kind of aiming for. So to give you an idea, then this is kind of sort of thinking that led to Prometheus. So Prometheus is inspired by Google's Borg-Mon monitoring system, which very conveniently even more details are public of since the S3 book, including basic language, which is suspiciously similar to Prometheus' language, which is very odd. We're not sure why that happened. So it was started in 2012 by some ex-Googlers, not including myself, in SoundCloud as an open source project to monitor microservices because stats-D wasn't working, and Graphite. Publicly launched a bit over a year ago, and it's independent of any one company. So ex-Googlers started this because, you know, when Googlers leave Google, their natural inclination is to start reinventing Google services. I've worked on, I think, 5 of them by now, different projects in different ways. Yeah, it just kind of happens. We've got support groups and everything. But other than that, like lots of companies are using it. I figure there's at least 200-300 companies using this in production. I can name about 100. It's an open source project. We obviously can't track everyone. We've got some surprising ones. We've got over 250 people who contributed to the code base inside the last year. And that was just at a year. It's probably a bit higher now. There's over 50 third-party integrations, including your own. So this is a very active open source project, which is kind of cool. Because the thing is, going back then to how we monitor things, I have this idea of inclusive monitoring, which is don't just monitor at the edges. Let's instrument everything. Instrument client libraries. If you have a MySQL library, right, or an RPC library, add monitoring in there. If you have your server library on the other end, add monitoring in there. And your business logic, unlikely to be shared across many projects because business logic tends to be specific, but add monitoring in there. So every place you go, you add some instrumentation. So if I import your library, I get your instrumentation for free. Like the RPC library is the obvious one. I got my latency and my error rate and the QPS. At least those basic stats are now sitting there. But if I'm the library author, this is also beneficial. Let's say I'm maintaining the RPC library and I'm playing around with compression. And I want to know, hey, how much data looks kind of random? I can add that metric into my instrumentation, wait for people to pick it up, go across the entire fleet, see who's using my library, pull those stats and say, oh, actually, a lot of that data is random. We should actually look out for that and not use compression in those cases and optimize for everyone. So that's great horizontal monitoring where a library author basically gets to look at the entire fleet. And also there's standard vertical monitoring for service owners where they go, hey, this guy's also included all my standard QPS errors latency and giving me a dashboard. Awesome. So across all your services, you can have that. Oh, look, someone's already done all the MySQL stuff. Percona, basically. Yep, it's all there. We can just turn that on. So everyone benefits from this. And when it comes to, OK, I can say, great, yeah, instrument everything. We take, there's lots of instrumentation clients out there that all they do is marshal data. You just give it information, it sends it out over TCP or UDP with some minor munging. That's all they do. Prometheus instrumentation clients do more than that. They're an actual instrumentation client. They take care of all the bookkeeping, all the concurrency, all the state tracking, all the nitty-gritty stuff. We've also optimized the hell out of them, at least in Go and Java. Other languages are a little trickier, unfortunately. And we take advantage of things like context managers in Python to make things as simple as possible. So this is a completely working Python example for instrumentation of how easy this is. So you pip install it. I'm sure Clara will pick that up if it's out of date. You import stuff, define your metric. Everything has a name, has a help string, because that's kind of handy to figure out what's going on. And we just use a decorator here to time every time this happens and chuck the answer out in HTTP. Complete example. If you want to instrument everything, you basically need these 2 lines for everything you want to instrument. Very easy to just chuck in there. Anyone can do it in any library that happens, as long as this line is somewhere in the code base so that it's exported out. And it also works with Twisted and everything else as well. It's actually someone submitted Whiskey yesterday in a pull request. Similarly, for things like counting exceptions and tracking progress, we've got a few decorators and context managers for those as well. Make life nice and easy. But the thing is that you're thinking, hey, if I use all this Prometheus stuff, that sounds great, but I don't want to commit myself to Prometheus and get vendor lock-in, because that's a reasonable concern, right? Everyone out there wants to get you locked in to their ecosystem. Like, I'm offering consulting services. That'd be awesome. I, however, have a slightly different stance on the matter. Our client libraries and so on, you can use them without using Prometheus at all. So both the Python and Java clients and the others, when they get around to it, will output the graphite, just as an example. So you could do all this instrumentation and add, I think it's 2 lines of code, or is it 3 lines, I think, in graphite? And yep, that is now going into graphite, no Prometheus involved. So you can have the option then of going out to whatever, and if your users, as a library author, wants whatever other monitoring system, they can just plug it in. You don't have to care, they don't have to care. Because like me, as someone who actually maintains a monitoring system, it is amazingly annoying to have to individually go for basically every single server that's out there and write custom code for however they've decided to deal with metrics. If everyone was using a unified library of some form, that'd be kind of nice. And it goes the other way as well, is that we can pull in data from lots of other monitoring systems. So SNMP, Collecti, SNMP, sorry, say that again, JMX, DropWizard, CloudWatch, lots of other things as well. So in principle, Prometheus can be a clearinghouse. So one example we have is Zalando has a tool called Zmon. Think a re-implementation of Nagios in Python that scales. But they actually use, that's basically what it is. And I think they're OK with me saying that. And what it is that they don't use Prometheus internally yet, but they do use one of our binaries, the node exporter. And they use the Python client library to go parse that information, pull it in, and set alerts on it. And that's all great, because it means they can reuse some of our code and do it entirely inside their system. And that's really handy. And of course, we have lots of integrations as well. So if you're using Docker a lot, we have CAdvisor. CAdvisor natively has Prometheus metrics, and there's a big long list, including Minecraft. Because, yeah. And the interesting thing really is I said there's about 50 of these. Most of these are written without the core team knowing about them. So that's how easy they are to write. And also Hydra has now a document on guidelines on how to write these, because there's a lot of non-obvious stuff. So another interesting thing about Prometheus, and there's a few other systems out there that do this, like OpenTSDB. If you look at Graphite, everything's dotted strings. And if you're really lucky, someone's thought ahead and made sure if there's a dot in one of those values, they've escaped it. Maybe they haven't. And you can only kind of use globs, and you've only got one way you can do that. It's kind of messy. Prometheus itself is all key value pairs. Even the name of the metric is actually just another key value pair called dunder name dunder. And you can slice and dice in these any way you want. So there's actually quite a few monitoring systems out there that have this now. Datadog has it, I think, for example. New Relic has it with custom metrics. There's a few others. It's a much more powerful way of doing things than basically throwing regexes and globs at strings, because we're actually getting the actual structure of the data out. And of course, it can come from instrumentation, or a previous example where you had my SQL database. The infrastructure guys saw it one way. The database guys saw that machine a different way. They can both have their own hierarchies and separate monitoring systems. So that's how you can approach that problem. So here's one example. This is just labels from the node exporter. This is our machine daemon. So you can see this is a Docker instance. Here's the machine. Here's the node. All the values going up. And dimensions, once again, really easy to instrument. That's an extra, 20 bytes of code? Pretty simple. The other interesting thing to note about Prometheus from a technical level is we have counters. Now, this may surprise people, but counters are things that only go up. You laugh, but actually most other monitoring instrumentation systems out there have counters that go down. Yes, drop wizard metrics, they go down, including all of its derivatives. This is a problem. So the way Prometheus works is we've got counters that go up. They can reset when the machine dies, because machine dies and we're not trying to persist it. And what we can do is, let's say a scrape fails because network weirdness happens or whatever. If you're got a lot of systems, they just take a exponentially moving average that's decaying over time. And then there's basically snapshotting that every 60 seconds or something like that. Which means if you miss a scrape, you've lost data, plus having to do calculus to reconstruct what actually happened. With Prometheus, if you just have a counter that's going up and you're taking a snapshot of it, if you miss one, well, you still know how much increases were there, you're just losing some resolution. So that's a little bit more reliable, because the general idea we have with Prometheus is that things fail, and we would prefer to give you mostly OK data rather than not having monitoring. So this is very much an AP rather than a CP system. And yes, we do automatically handle counter resets. So all of this combines into a powerful query language. You can basically do anything you want. How powerful is the query language? It's Turing complete. How do I know it's Turing complete? I implemented Conway's life in it. The demo's online publicly. Actually, it's currently a 16 by 16 grid. We made some efficiency improvements and can make it larger now. But if you want to ask questions like, across my European data center, what's 95% latency? That's easy to do. How full will this be in 4 hours? Any of you who know disk thresholds are really annoying? Because 95%. Yeah, it filled too fast for us to notice. 10 gigabyte. Yeah, we're using 5 gigabyte drives. You know, what does work better, not perfect, but better, is based on the last hours of data, where will we be in 4 hours' time? If that's full, page me. So that sort of approach can work out better. Also, you can take the, do any aggregation or match you can think of, basically, especially since I finally put in, I think, the final touches. Actually, no, I've got one more PR to do, but the language can basically do anything you want with labels. And also, we have no distinction between graphing and querying. Sorry, between graphing and alerting. It's the same query language. So if you can graph it, you can alert it. And here's got one example. Let's say all the Docker ones by image across the entire fleet. Give me the top 5. So see which Docker images are spending the most CPU. So maybe we can start optimizing things there. In the same way that with Clara, you might say, hey, let's look at these images because they're our biggest problems. You might look here and say, hey, these images, well, they're our biggest CPU problems rather than security problems, and just say, let's focus our effort there. As well, like, it is simple to run. It is a single binary. We're all about reliability. It doesn't depend on Cassandra, Hadoop, Zookeeper, or anything else like that, like the internet. Because the thing is that this is a critical monitoring system. You know what I really don't want to break when my network falls apart? My monitoring. And if you're depending on things like Zookeeper or Kafka, which are basically CP systems, in the case of Zookeeper, an extremely strong CP system, the chances are if your network's falling apart, that's also going to take out your monitoring, which is not what you want. With Prometheus, it'll keep on working. The only thing it needs is local disk and network access. And it'll just keep on going as well as it can during that time. And that also means cascading failures are not likely. Because distributed systems are really, 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 really hard. We want to avoid those problems. Because it's critical monitoring, you don't want that sort of risk. You can put that elsewhere. And it is, because it's pull-based, I can run it on a workstation. So one of the interesting, like, pull versus push is a massive religious issue when it comes to monitoring, right? I've seen flame wars like you wouldn't believe. Like, I remember when Prometheus was released, there was a Twitter one saying, hey, this is a pull-based system. Haven't we learned by now that pull doesn't scale? It's like, really? That's news to me. Scaled perfectly well last time. But, you know, it's like, you can scale both push and pull, right? It is my opinion that pull is slightly better. It has a few advantages. But it has some disadvantages which you can work around. Push also has disadvantages which you can work around, right? In reality, the difference is pretty small. Like, it's a tiebreaker at best. Pull is slightly better. Now, for example, because it's pull-based, if I want to run a Prometheus on my workstation to just test something out, I can. The equivalent push-based solution would require you to change every single machine to also push to your workstation, which would probably also be fun network-wise. Less plausible. But, you can work around all these things. Someone could create a service to send a second copy of the data in, But it is simple to run. It also means every team can run their own. So in the case exam where you have the MySQL team, the infrastructure team, each of them would have their own Prometheus server with their own taxonomy of labels and their own view of the world without having to talk to each other. They're completely isolated, their own rules, their own alerts. It all works out. And it means as well that ops aren't a bottleneck to get all your monitoring changes done. You just change them because you're running the Prometheus. And because it's pull, people ask us, how do you find the machines? Well, we'll ask like EC2 or Kubernetes or Marathon or Console or whatever it is. And relabeling as well makes this all work. Because it turns out, so the idea of service discovery is we'll go to EC2 and say, hey, give me the data. And say, hey, yeah, here's all the instances. Grand. So what labels do you want on those? Which tags? Or are you using security groups? Or are you using, or are you doing it based on VPC? About half of the new service discovery methods that we got in as pull requests had hard-coded assumptions about that particular user's environment. Because it turns out if you have 100 different companies doing this, you're going to probably have 150, 200 different ways they want to do service discovery. So we use the standard fallback you always use when everything is just all over the place, there's no standardization. We throw regexes at the problem. So we basically take all the labels and say, right, put them together, concatenate the ones you want with semicolons, throw a regex at it. If it passes, then yes, we'll grab that instance. And similarly to do all the other stuff. It works out pretty well. We've also had to deploy that technique in JMX, which turns out is quite non-standard. So yep, final fallback you always take, we use regular expressions. And it is pretty easy to run, as I said, and it's actually really efficient. I think we're now actually the best system we're aware of out there, better than Gorilla, because we took their paper and improved on it slightly, at 1.3 bytes per sample. So that's pretty small. We used to be 4.5. And a single Prometheus server can handle 800,000 samples per second because it's been optimized a lot. For reference, that's more than enough to handle 10,000 servers from a single machine. So that's pretty efficient. And with all those Prometheus servers, you can pull data between them. And there is the option of sharding and federation to scale out further horizontally. You probably won't need it because 800,000 samples is a lot. But if you have thousands of machines in a single data center, you might want to have to go to that, but avoid it if you can. There's also many dashboarding options. Got something built in, good for ad hoc. Full web templates from Dash's Ruby on Rails, things that's kind of deprecated. And we have Grafana, we've got first-class support in there. So the Rain Tank guys are really big fans of it. So just to sum up what I've gone through, we have the instrumentation that you can use, and that's completely separate, that you can use independently of Prometheus. We've got a data model and query language that's great for analysis. You can alert on any query. The architecture means you can decentralize this and hand each microservice team a Prometheus for themselves. And that we've got a service discovery that's going to pick up new services automatically if you set it up right. Like you can imagine that just if you've decided on a schema for your tags in EC2, for example, that it'll automatically pick up new services based on that. So that's the sort of thing you can do when you're throwing regexes at key value pairs. Which means Prometheus is a great way to monitor your microservices. So I'm going to do the quick demo and then get on to 5 tips for monitoring microservices. So let me go here. So this has just been running on my laptop. I set this up quickly. So here's the Prometheus. It's really fancy. Some built-in graphs, for example. Hey, you can see it's been up. This obviously doesn't mean much, but I can say process, CPU seconds total. Here's the CPU going up since I turned that on 30 minutes ago because I'm not hooked into the Wi-Fi. I think it did literally take me 20 seconds to set all this up because I'm used to it. And then if I actually wanted to rate that, because that's a counter, 1 minute. There we go. And here's the actual rate of CPU usage on my machine. Obviously, this is not the best interface because the Y labels there are all 0. And you can actually see how it exposes the metrics. Localhost 9100 metrics. So this is the node exporter or machine daemon. This is running in its default configuration. It exposes 500-600 different metrics by default. And you can see the labels here. So it's a text format. It's pretty easy to write in any language, which is why we've got like 10 languages so far. And we basically go through all of /system/proc and dump it. At least everything useful we can find. Cool. So how are we doing on time? 5 minutes, okay. Then we're going to have a very fast look at 10 tips for monitoring microservices. Now these are not Prometheus specific, but if you've got lots of data in something like Prometheus, it's very hard to know what is and isn't useful. Like I would consider a well-instrumented binary to have between 100 and 1,000 metrics, and that's before labels come into play. That gets noisy fast, right? Like if everyone has their RPC compression debugging variable in there, that's a lot of data. So approaches to help you manage that and avoid getting caught out. So as I kind of been mentioning a few times, the first one is know what your key statistics are. You don't care if your machine isn't stored to CPU, you care if your latency is slow. You care the SLAs that are in your contracts with your users, look at that, and focus on these metrics in your dashboards. Similarly, you want to think about services, not machines. Because once you go beyond a handful of machines, and I do mean a literal handful, you should basically treat your services as your machines as an amorphous blob of compute. It also helps things scale, because if you've got 10 services, that's already a lot of information. 10 services split up by 10 machines, good luck with that. That doesn't work. But the thing is, once you know which service is a problem in your architecture, well, then you can look at the machine view and say, oh, actually, that machine's dodgy. Right, kill it, we'll fix it tomorrow. So it's just basically walking the stack and limiting how much you look at it once. Which brings me to avoid the wall of graphs. This is a very common anti-pattern. Dashboards, they just tend to grow without bounds, right? It turns out that you need to watch architecture this and do refactorings and cleanups just like with your actual code. The worst I've personally seen was 600 graphs. I've heard of a 1,200 graph one. So these things are impenetrable, usually also for the person who creates them after a month or so. They also take forever to load, because as you imagine, that's a lot of data. So the way I'd say is, like, if you think you're microservices, it's a tree structure, at least for each external X service. So just walk the tree. If you've got a latency problem, start at the top, see, hey, is the server overloaded? No. Which of the backends is slow? That one, right. Is that service overloaded? Yes, no, no. Which backend? Grand. Is this service overloaded? Yes, grand. This one's overloaded. Right. Now look at the subsystems and dig down like that. Rather than, looking at a million graphs and trying to hope you're going to find the right one. Just explore it as a scientific investigation. What's going wrong? Or differential analysis. A little bit of statistics and math. Client-side quantiles are not aggregatable. It is not mathematically possible. You can use them to get bounds by taking minimax, but you cannot actually do it. So if you do want quantiles, the way we do it in Prometheus with our histograms is we have buckets, which we can then aggregate and then take a quantile of. So each machine says, hey, we had this many under 10 milliseconds, this many under 20 milliseconds, aggregate that all up across the service, and then calculate the quantile. And it turns out histograms and quantiles are a little overrated. I have a service, simple service with 2 backends. 95th percentile latency goes up because of one of the backends. In that backend, what will I see in the 95th percentile latency? Anyone know? Any guesses? The answer is, who knows? It really, really depends based on the correlation between the 2 services. Because the 95th percentile is saying throw away 95% of my data. So depending on what's going on, it can be really hard to figure out. Even medians have this problem because you're still throwing away half your data. And reasoning about this stuff is not what you want to do in an emergency. This is not a problem with averages. Averages are cheap. Averages are easy to reason about. Like averages a lot. Percentiles are still handy. Have them at the edge of your systems. Know what your user experience is. But when it comes to drilling down through your microservice tree, use averages. at least to figure out where you should be looking. And then once you find a service to blame, maybe then look at the quantiles. But when digging down, averages work out better. Another thing is that monitoring is not free. You know, if it was, I imagine the SaaS companies providing monitoring would be in quite a bit of trouble. But think about it, if I have 1 resolution set metrics for all, 1 second resolution data for all monitoring, that would be really handy. But is it really worth 10 times as much resources as 10-second monitoring? Or 60 times more resources than minute monitoring? The answer is no. Like going from a minute down to 10 seconds is maybe 20, 30% more valuable. Going from 10 down to 1 is like maybe 10 to 20, except for some very specific use cases where it really matters, for like microbursts. So always have that balance in mind. Histograms and quantiles are also quite expensive because histograms have so many buckets, and quantiles are quite expensive on the client side. Like you could easily be looking at microseconds to handle those, whereas an average is nanoseconds. Something to keep in mind. My personal advice is 60-second resolution works really well. Keep 1 second granularity for key statistics highly aggregated. You do need them for a few things like microbursts. Quest Shannon, just going to go over this quickly. You can only sample so much. This doesn't mean if you need basically twice the resolution for what you're trying to look at. It's information theory. Correlation is not causation. I'm going to skip this game for time constraints. But the thing is that humans are really, really good at spotting patterns. Really good at it. Including patterns that aren't there. Which is a bit of a problem when you're doing monitoring. Because you'll say, yes, these two spikes happen at the same time, but that doesn't mean they're actually related. It could just be pure chance. They could just happen to be on the same schedule. It could be that, well, actually, if you look and zoomed out, you'll notice that, well, one of them happens every 15 minutes and has been happening for years. The other one's new. Or maybe, and this is actually what normally happens, one of them is slightly increasing contention that's just causing some other problem to appear and arise. So that's something just to keep in mind. But always try to zoom out and think, right, if I was looking at this, what's some other metric I'd expect to see and double checking it, just to verify. Otherwise, you're going down on a wild goose chase. Another one is logs and metrics. Lots of people think logs is the be-all and end of monitoring. It is not. I'm also happy to say metrics are not the be-all and end-all of monitoring. There's a balance here. Logs, you can only have about 50 fields before you run into bandwidth issues. Metrics, however, can't have high cardinality. So logs, at least you can get every event, you can get a few things. Metrics, you can get many, many things, but you have to aggregate across time. So they're useful for different things. Metrics are useful for your initial analysis to figure out which subsystem to look at, and then you break your logs, your profiling, your GDB, and so on. And that's how to use them nicely. And an important one, and this is the last one, is have a way to deal with non-critical alerts. Because a common way to deal with things that don't page is to send them to email to a team. And all your engineers, or at least I hope all of your engineers, will over time filter those away and ignore them. Because that makes sense, right? And they're continuing to be ignored until after the outage, because there's always an outage. And then someone will ask, why did no one read the alerts? It's like, well, why would you? They're all spammy. And there's much touching and, oh, this is terrible, we could have avoided this outage because one of these alerts was relevant. Yeah, among the noise somewhere. So you really do need a process, a credible process for non-critical alerts. Ticketing system works, where you have actually someone assigned to look at these. Or I've seen also just a daily email of what's currently firing. I've also seen that work. Actually using email, I've only ever seen 2 teams ever manage to do it correctly. And that was when one team split, was doing it correctly. Right? Email does not work for this. It works when you have 2 machines. It does not work beyond that. And finally, just to say that time series monitoring is great. Prometheus is efficient. It's easy to get over your head. Keep things simple, as with all designs, right? If you are coming up with an expression that's really, really, really complicated, you've probably overtaught things. The same as you would have in other languages. And as I said, we do consulting and training around Prometheus and general things. And I will take questions. There's various links there, including the live demo with Conway's Live. Ooh. Any questions? Yeah?
So we're in the process of splitting our monolith into smaller services. And what you said about the architecture being a tree structure rings a bell. And right now, we're using new relevant data for monitoring.
Yeah.
And I didn't see that sort of view. And is there any sort of ability here to destruct the model that
Okay. So the question is that you're currently splitting your into microservices and using some SaaS options. And is there a tree view, like I mentioned, inside Prometheus? The answer is no. Automatically detecting one of those is hard. There is technology out there. I think Weave is a company who's actually doing that in particular. But with Prometheus, your answer is, yeah, add your own dashboards by hand, which I think is a similar answer. Datadog, I think, is the same. New Relic, I'm not sure there's the option. Might be these days.
And I'd be willing to build it.
Yeah.
Destroy it. I don't believe creating that automatically would be easy.
Yeah.
Even having to draw it, I haven't seen it.
Yeah. So yeah, there's nothing there to really draw it. It's just how you organize your dashboard list. The discoverability of dashboards is an unsolved problem, in my opinion. Just like discoverability of documentation is an unsolved problem. But at least we've got fewer dashboards. Any other questions? Yep.
You mentioned that Prometheus handles a lot of second very well. Does it also handle large amounts of log data and potentially noisy services, given that it's on a single server?
So the question is, does Prometheus deal with lots of logs data well? The answer is Prometheus does not deal with logs data at all. It's a metric system. Oh, sorry, what's it? Sorry, I mean, with variable bus data, you said it? I'm not hearing you. Get a little closer.
Since Prometheus is just on a single server,
Yeah.
how does it deal with large amounts of metric data that's generated by very noisy services?
Okay, so the question is, how does Prometheus deal with very large amounts of data generated by noisy services? So in general, things are pretty steady state because you want not to have too many labels. If you send it too much data, it'll basically start dropping stuff on the floor and firing alerts saying, I'm overloaded. Or you should set up monitoring to detect those metrics. It can be overloaded like everything else. And there's ways to deal with that tactically. Basically, just as you can choose which instances you want to monitor, you can also choose which metrics you actually want to pick up. And at least just drop them on the floor while you fix the code. There's a blog post up there explaining how to do that. Another question there?
You said there was an alerting mechanism with querying language.
Mm-hmm.
And that was built in. I didn't recall Prometheus having an alerting feature.
Okay. So the question is about the alerting feature inside Prometheus, because the gentleman doesn't remember it being there. So Prometheus itself, PromQL, just fires alerts to what's called the alert manager, there's one of them. It's currently a spot, but there is only one of them, so it's practical to do manual failover. And it then takes alerts from multiple Prometheus services, deduplicates them, groups them, applies silences, and sends out notifications, things like PagerDuty and the rest. Because it duplicates, like Prometheus doesn't have any distributed way, doesn't have any inbuilt reliability. So the way you do HA is you run two of them identically, who don't know about each other. And they're both sending alerts. Alert Manager deals with that, and then sends out the notifications as needed. So that's roughly how it works.
The alert manager is separate from Prometheus?
Yes, the Alert Manager is a separate binary from Prometheus. The idea long term is you would run one alert manager, or at least one cluster of alert managers when we have that feature per organization. So there'll be one per company. Yep. No question? Okay. The question is about confidentiality and security. So Prometheus itself has no security features. Well, there's some flags to turn off the more dangerous features like deleting everything. So when making requests out, you can turn on SSL auth, basic auth, a bearer token. When it comes to securing Prometheus, like talking to it, we have not implemented anything. The reason why is that there are just too many ways to do it. So like SSL alone in Go has, I think, 13 different options the user could plausibly want to adjust. Like all the cipher settings, all the CAs and so on. And that's just SSL. Basic auth, it's grand. You think, yeah, I've got this password file, yes. But what if it comes from LDAP or Kerberos or Active Directory? And then this expands quite complicated. So our approach to this is use something like Nginx or Apache, which has all the modules, and push it in front of it. And that's generally how we approach security. The other thing then is, okay, that's basic raw access. What about actual row level access, data controls? We have nothing like that. You could probably figure so if you're using Grafana, you could lock it down and put it in proxy mode, so you can choose what dashboards are in use. That's an option. If you're using console templates, you could also lock things down there. But if you can get to the query endpoint, you can do anything. But if you can put a front end in front of us and then restrict that down, that's fine. It's my general presumption that any data inside Prometheus is at most commercially sensitive. It is not something you'd want to be putting PII through. It is definitely not something you want to be putting HIPAA through. We did have someone, I think 2 years ago, appear and say, can we use this for actual human health data? And we said, hell no. Please choose like Postgres or MySQL or not this. This is not built for that. Because we're okay with not having perfect answers. We prefer reliability. Okay, and probably one last question on time. Yep. Okay, the question is, what are the next milestones for the project? So at the moment, we're kind of working towards a Prometheus 1.0, just to give API stability. Some of the things we like to have is a HA alert manager. So as I mentioned, it is currently a single point of failure. Because there's only one of them, that's kind of okay, but obviously that's not optimal. Long-term storage is another thing. We consider Prometheus storage to be more cached than anything else. So it could be for a few months. But if you have data corruption, our answer is blow it away, start it back up again. And you prepare for that in your alerts and rules and so on. So we want something else to take care of long-term storage because that fundamentally requires a distributed storage system, which we want to decouple then from the core monitoring for reliability. So that needs to be developed. And then more exporters and so on. More efficiencies, because we keep on getting things more and more efficient. Cool. Right. UI improvements would also be nice, because none of the core developers really are UI people. Okay, I think that will just be about it on time. Thank you very much.